1 gram of calcium oxide reacts with 250 milliliters of water to form calcium hydroxide. If the water goes from 25 to 26.08 degrees Celsius, assume density and heat capacity of the solution are the same as they are for water. So how would we go about solving this? What equation do we need here? Yeah. Yeah, we need Q equals MC delta T, right? We need Q equals MC delta T for the water. Right? So the heat of the water, Q of the water, right? Our mass of our water. So our total mass, right? We add 1 gram of calcium hydroxide to 250 milliliters of water, right? The density of water is 1 gram per milliliter. So we have 250 grams of water plus 1 gram of calcium oxide. So we have a total of 251 grams for our total solution. The heat capacity, right? The specific heat of water, they don't tell us that in this problem, but the specific heat of water is always 4.184 joules per gram times degrees Celsius. So 4.184 joules gram degrees Celsius. And then our delta T for the water, right? The water goes from 25 to 26.08. So our delta T is 1.08 degrees Celsius. Multiply all those together, and we get the heat that the water absorbed. Was that your question, Gustav, as well? How did we get 250 grams? Right. We have 250 milliliters of water, and water is 1 gram per milliliter. So we have 250 grams of water, and we have 1 gram of calcium oxide. So our total solution, right? Our total solution is the mass of the water, the mass of the calcium oxide. So 251 grams is our total solution that's going through this temperature change. Right, we multiply those all together, I get 1,134.2 joules. All right, I'll give you a minute to think about what does that make our heat of reaction, right? And this question's up on Top Hat right now. So if that is the heat of the water, what's our heat of the reaction? Anyone else with the handouts? Seriously printed more today. Pass that over for me. Anyone else? We're good. Way down there. They got stolen. I sent them. Oh, sorry. Yeah, I think it's no, but it's saying the temperature of the water. What's a calorimeter? Kilometer? Yeah.
I mean the
Heat of the reaction. What is our heat of the reaction? Yes, Sada. Okay. Yeah, all right. So Sada had a question before we get to the heat of the reaction, right? How do I know what equation to apply? Right? We know a mass of water. We know the water's going through a temperature change, right? We know the specific heat of water is joules per gram degree Celsius, right? So we know this is going to be a Q equals MC delta T because I have the mass of water. They didn't give us, but we know the specific heat of water and the temperature change that water went through, right? The other equation that we know is Q equals C delta T, and that's the heat capacity. Heat capacity is just joules per degree Celsius. There's no mass component here. So that would lead us down the wrong path because we have mass. We know the mass and we know our specific heat is per gram. So we need that mass, right? So that's why we need to know, we need to use Q equals MC delta T. Mass, change in temperature, specific heat. I would give you the specific heat of water. Yeah. Yeah, Gustav. We don't need to, right? We already know the heat of the reaction, right? What's the heat of our reaction? Yeah, right. The water absorbed this energy, right? Water absorbed 1,134 joules. So our reaction lost, right? 1,134.2 joules, right? So what would that make our final answer in kilojoules? Yeah, negative 1.13 e to the 0. 3 significant figures, right? All right, any questions on 34? Yeah. So Q for the water, that's what we observed, right? The water went through this temperature change. And because the water absorbed its energy and went up, right? Q of the reaction, right? RXN is reaction. So that must mean our reaction lost the same amount of energy that the water gained. Yeah, it's always going to be the opposite of what happens to the water. We can't track the reaction, right? We can track the water and use that to figure out what happens with the reaction. All right, any other questions? Yeah, way in the back in the middle. Because, right, 1,134, we convert this from joules to kilojoules, so I divide this by 1,000, and that makes it 1.13. In scientific notation, 1.13 is 1.13 e to the 0, yeah. Yeah. You're asking about this right here? Yeah, our reaction will always be the opposite sign of what happens to the calorimeter or what happens to the water, because again, I can't put a thermometer in the calcium oxide and monitor that temperature change. I can monitor the water temperature change, find that energy that the water absorbed, and yeah, the reaction should always have the opposite sign of energy. If the water absorbed that energy, right, the reaction released that energy. All right, could we just quiet it down a bit? All right. Yeah. To find out for the water, right, the water goes up in temperature, so the water had to absorb energy. right? Our delta T is always final minus initial, so 26 minus 25. We're gonna have a positive temperature change for our water, so we should have a positive Q for water as well. Yeah, there's two ways. You can get it from here and from here, yeah. All right. We'll try one more problem here from your homework. Right, this is question 43 from the reading as well. Right, zinc sulfide reacts with HCl to form zinc 2 chloride and hydrogen sulfide. Right, this is a summation calculation. So who wants to set up the summation calculation for us? Put the products in, yeah. Yeah, the subscriptions too, not the coefficients. Right? All right, so our delta H equals the sum of, right, I've got 1 mole of zinc chloride. Zinc chloride is minus 415.1 kilojoules plus 1 mole of hydrogen sulfide, that's minus 20.6 kilojoules, minus the sum of, I've got zinc sulfide is 1 mole of that at minus 201.1 kilojoules, and then I've got 2 moles of HCl, and HCl is minus 92.3 kilojoules. All right, we multiply, we can add those together. I get delta H equals negative, what? 435.7 kilojoules minus a negative 385.7 kilojoules.
So for on the test for these type of questions, are you gonna give us the delta H or
I have to, right?
or the chart?
I would give you the delta H values because there are hundreds of them, right? You
Right.
can't memorize all the
Okay.
delta H values, yeah. All right. We get our delta H, right? Somewhere here, I've got my laser pointer, right? So we've got this, we're gonna subtract, right? This positive, so we're really gonna add this across. I add this across. And I get a negative 50.0 kilojoules. Because again, addition and subtraction, I've got 1 decimal place here, 1 decimal place here. I need to have 1 decimal place in the final answer. So even though it's 0, I know it's 0, I know it doesn't change the number. We have to include it when we write that number in on the homework, right? We can't just say 50, we have to say 50.0. So in scientific notation, right, this would be negative 5.00 e to the 1 kilojoules for this delta H. So I think, again, many of you that are having problems with these questions, you're probably doing it correct, right? You're getting a correct number. It's just a significant figure error on the back end. So there should be 3 significant figures there because I have to have 1 decimal place in the answer. So 50.0, that's 3 significant figures in scientific notation, right? Negative 5.00 e to the 1. Any questions on 43? All right. Let's try question 42 from the homework now. Homework question 42. Right, we've got a 55.9 gram sample of water at 99.21 degrees. And then to that, we add zinc metal at 21.1 degrees Celsius. And the water temperature drops to 96.1 degrees. What is the heat capacity of the zinc metal? Just for fun, I tossed this question to Chat GTP. Chat GTP got this question wrong, so can't solve all your life problems with Chat GTP. All right, I'll give you a minute to think about this problem. I'll walk around and we'll come back together and we'll go over this calculation.